Hello friends, today we are going to discuss about the disk scheduling in the mass structure systems. The operating system is responsible for using the hardware efficiently. So for the disk drives, this means that having a fast access time and the disk bandwidth. So in disk scheduling algorithms, we use things to reduce the total seek time of any request. Input output request issues a system called the operating system. If the desired disk drive or the controller is idle, then the request is served immediately. But if the device is then the request for the service will be placed in the queue for the pending request. So when a request is completed, the operating system has to choose which pending request to service next. So, to service a request, a disk system requires that the head to be moved to the desired track, then wait for latency and finally transfer the data. So, it's completely the meaning is what we have seen earlier, that the disk arm should take the header to a particular cylinder in that of a platter. In that particular cylinder, there is a track. In that track, there is a sector. So this all things will need time, and the processor may request a sector number 35 a processor, then after 35 it may request a sector number 58, then after it may request a number 1 sector number 1. So the arm has to move around as per the disk rotates. So this how this scheduling is done, how the arm movement and how the disk movement or rotation is being arranged, so that everything, all the processes requesting for a sector, all the requested are processed in minimum amount of time. That is what is disk scheduling. So there are two major components. The first one is the seek time. This is the time for the disk arm to move the head or the heads to the cylinder containing the desired sector. And next one is the rotational latency. It is the additional time waiting for the disk to rotate the desired sector to the disk head. Okay, so first one is the seek time, that is arm moving to the desired sector, and next is the rotational latency, that the disk rotating the desired sector towards the head. So this is what, and this entire process we need to just minimize the seek time. This is what we look forward. And we also need to know that the seek time is always proportional to the seek distance. That means at what distance the sector is, and the header at the header's current position, from the header's current position, to what distance to what distance the sector is, the desired sector is, so that much proportional time is required to find it. Next we have the disk bandwidth. This is the total number of bytes transferred and divided by the total time between the first request for the service and the completion of the last transfer. So you need to keep these things in mind. So there are several algorithms existing for it, and for those existing algorithm, we'll just look forward for the FCFS. What is FCFS? It is the first come first served algorithm. The first come first served algorithm will do what? In this algorithm, we have a certain request, and it is called a queue. What is this queue? This queue says that, as we have seen in the few words I've said before, that if the arm or the system is idle, it will immediately serve the request. But if it is busy, it will keep the requests in the queue. So that is what is queue. The first pending request is 98. This 98 reflects the sector number 98 in the disk or in the platter. Next is 183, which again reflects the sector number 183. Then 37, then 122, then 14, then 20, 124, 65, 67, and so on. This we need to fulfill. And according to FCFS, that is the first come first serve basis algorithm, here the working is very sequential. Who will request first? that request will be accomplished or will be served first. So so 98. So and the head start. So head start is what? That um, the current position of the arm is at the sector 53. So the current position of the arm or the head is 53. So we are going to traverse from 53, and we are going to traverse in sequential order, as the algorithm says that you should move in the sequential order as you have been requested. So the request is first is 98 in the queue, then it is 183, and such is the order, and so on. We should go with that. So like what we can do is we can have just the, you can see the graph over here, that the head start is 53. From 53 it needs to go to 98. Now as you know, it is sequential. From 53 it will go to 98. Next you have is 183. So from 98 it will go to 183. From 183 next is 37. So again it will go back to 37. Next is 122. Again it will go back to 122. Then 14. Here you can see here this line, this particular line is showing you the measurements. Then after 14 it is moving to 124, and then from 124 to 65 and 67. So again we can see, according to this scale or the rule, you can see that here we have the 53. We are starting the head start at 53, then 98, then 183, 37, 122, 14, 124, 65 and 67. So what you need to do over here is you need to find the average seek length. That will give you how much average seek time you are requiring. Because why? What we have seen in the previous slide, we have seen that the seek time is always proportional to the seek distance. That means if the seek distance is more, the seek time will be more. If the seek distance is less, the seek time will be less. Okay, so that for that reason we need to find the seek length, that is the seek distance. And as we have many more requests over here, so we need to find the average of it. So let's have a small calculation on it. Okay, this is some like other example I've gone for. You can just delete it things over here and we can go for it. So for our head start is 53, and our first encounter, our first request is let's go back. Our first request is 98, 183. Okay, fine. This is 98. Okay, then 183. Next you have is 37, 122, 14, 37, 142. Okay, I just forgot it. Okay, it's 122, 14, 124. 14, 124. It's 122, 14, 24. And then we have 65 and 67. You go up to that.